Welcome everyone, wherever you are in the world, and thank you for joining us. I'm Brenda Dettinger from BIOPAC, and I will be your moderator on today's webinar, How to Synchronize Participant Video with Your Physiology Data. Today, we are exploring the hardware and software researchers use when they want to add video to experiments. There are a lot of benefits of adding video. We'll cover those in the next hour, plus we will explain how to set up the equipment and the software. We'll do a live demo of data collection with video. This webinar is being broadcast from a special lab called the Emotional Affect Media Center, also known as the BioCube, here in downtown Santa Barbara, California, where it's raining, and we're grateful for the rain. We'll explain more about this type of lab in a minute. First, I have some housekeeping for you. All attendees are muted to keep our lines clear, but we do want to hear from you. So submit your questions through the GoToWebinar control panel on the right of your screen. Click the arrow to slide your control panel out or push it back out of the way. We do have a very full agenda and we have a lot of different things to show you, but we do plan to take questions live throughout the webinar, and hopefully we'll have time for a few questions at the end of the webinar. Today's webinar is being recorded and we will email you a link to the recording as soon as it's available. Finally, we ask that you complete a short survey at the end. We'd love to hear your feedback on this webinar and future webinars. Now on to our presenter. I am excited to introduce our speaker, Frazer Findlay. Frazer is the CEO of BIOPAC. He has over 20 years of experience in the life sciences and physiology monitoring industry. He's very well versed in data collection and analysis and always has a ton of information to share. Welcome, Frazer.
Good morning, everybody. Good morning, Brenda. Hopefully everyone can see my screen okay.
Oh, hang on, let me make you presenter.
Thank you, Brenda.
There we go.
Okay, so hopefully now everybody can see my screen. Good morning and welcome. Thanks, Brenda, for the introduction. And thank you all for joining us this morning for our webinar. Okay, so before we get started, I just have get set up here. Bear with me one moment. Yeah, before we start, I have a little background information. BIOPAC develops high-quality scientific tools that allow you to measure physiology anytime, anywhere, from any subject. We've been in business for 28 years, and 99% of the top 100 universities use BIOPAC products. BIOPAC has over 32,000 citations, and the BIOPAC Student Lab System is ranked #1 for physiology experiments by members of the Human Anatomy and Physiology Society. In this morning's webinar, we're going to review everything from video camera setup, the actual hardware setup, and then look at different types of video option. There's a number of different ways of doing that, and we'll be paying some special emphasis to synchronization, so making sure that the video is synchronized with the physiological data that you're collecting. Now, for the purposes of this webinar, I'm actually using human subjects, but this can be done in a variety of ways, whether you're using animal or human subjects, it really doesn't matter. It just so happens that I've got a very willing volunteer, Sadaf, who's going to be joining us a little bit later on. I've got her set up and we'll be running through some of the video collection and synchronizing it with her physiological signals. As Brenda's already mentioned, we are coming live from the Emotional Affect Media Center in Santa Barbara. This is a lab that BIOPAC has set up for recording 4 participants simultaneously. So we can have 4 people in the lab We've got video cameras on each of them. We've got a control room, which is where I'm sitting right now, and I can view each of the participants. I can communicate with them on an individual basis, and it's really designed so that participants can take part in a study or collectively, or each person running an individual protocol. So it just depends on how you want to set it up. That's the lab. Within the lab, the actual structure, it's basically a product that BIOPAC is going to start offering. It's basically a lab in a box. It's called the BioCube. Give you a little bit more information about that. The BioCube itself is basically everything you need in one container. So you get all the wiring harnesses for your data collection, the video cameras, the monitors, the furniture. If you've already got your recording system, we can wire in existing recording platforms. If you're starting from ground zero and you need everything, we can provide the recording systems as well as the infrastructure for running the lab. This is sort of a little bit like flat pack furniture. It arrives in some rather large boxes. Someone from BIOPAC will come along and build the lab, and within 48 hours you have a fully functional lab that will allow you to collect data from 4 participants is the default setup, but you can add on quads to record from 8, 12 or 16 participants. One of the nice things about the system, it folds flat. You don't have to worry about any of your wiring or anything like that. Everything is completely integrated. When we install the system, we provide training on our products as well. So you get a complete lab setup where you're ready to go very quickly. Here's a view of what the system looks like. Basically, you've got the 4 BioCube participant quadrants. They each come with 2 types of chair, either a media type chair, which is movie theater style reclining, comes with a large monitor on a stand. You can mount eye trackers to it. The cameras are mounted to that for monitoring the participant. Comes with noise cancelling headphones, basically everything you want, including a table. Then adjacent to that, we have the control room. The control room includes a table for all the computers, the monitors, and everything else. And then there's a preparation module. Comes with stools, a cart with storage containers for holding electrodes and other supplies. And basically the participants are prepped in the preparation module, and then they're walked around to their individual cubicles where they take part in the study. There's an intercom system, so the person in the control room can communicate with each of the participants individually without interfering with the different sessions that are running. There's a top-down view. So in terms of dimension of the space, 24 by 17 feet, or if you prefer metric, 7.3 by 5.2 meters. And all you need is a clear space. This system drops in, and suddenly you've got the perfect lab ready to start collecting data. Anyway, that gives you a little bit of information about where we're actually coming from today. Now what I'm going to do is move on with the actual physiological data collection and video integration portion of it. So let's start with a quick demonstration. I'll show you how I've got everything set up. If I bring acknowledge up. Okay, so here on the left-hand side, I've got acknowledge. For those of you that are familiar with it, you may have noticed we have this menu on the end, media. Media allows us to determine the type of camera that we're going to record from. It allows us to set up the audio as well. We can name the output file, but the system will automatically do that for you, and it will take the name of the acknowledge file and use that, but you can set a different path for the video. So if you're recording continuously 24/7 and you're generating huge video files, you can put the video files on a separate drive. And then for playback, we can link the media so that we're able to play back part of a file. In addition to that, if I cancel out of here, when we come under preferences, this is in the latest version of Acknowledge. I'm running 5.0.3. If we come into the preferences, this is this little icon here, looks like a wagon wheel. There's an option down here, video capture, and this allows us to configure the video camera. What I'm going to be using today for the demo is just a generic Microsoft LifeCam. USB plug-in, very, very generic. It works pretty effectively, actually. If I come into configure, I can control the brightness and all manner of different things to make sure that I've got the camera functioning correctly. I can also control the frame rate, so we can drop the frame rate down so that we get better resolution. And I can also control the AVI compression. So I'm running today in a very compressed mode. We are a little bit band limited with our internet connection from this lab. So I'm kind of compressing the video, plus GoToWebinar is also compressing the video. So unfortunately, what you actually get to see on your screen is not really the same as what I'm seeing on my screen. It's just the nature of GoToWebinar and how it tries to be really efficient with the bandwidth that it has available. Anyway, if we select OK here, if I come into show capture viewer, actually I already got that open, I come down here. And good morning, everyone. I've got the camera on. I'm sitting in the control room, and as I move around, the camera's going to try and refocus on me so that it's got a good image. The camera is just sitting on the shelf right in front of me. And what I'm going to do is I'm going to show you how to set this up so that we can synchronize with the video to the physiological data. So at this point, I'm going to hand you back over to Brenda for our first poll of the day.
Hey, thanks. Everything looks great in spite of the potential bandwidth issues. So, all right, the first poll, do you currently video your participants? If everyone could respond, I see the responses coming in. And also, just so you know, you can interact with me and ask questions using the questions pane. Go to webinar. Stefano already asked a question, and Frazer, I'm going to go ahead and ask it, even though I think he already covered part of this. At which frame rate can you record, and what is the video compression? What's the level of sync, or does it depend on the camera?
I'm going to cover all of that. What I've got, what I just set it to there, it was at 30. I think I left it set at, I dropped it down to 20 frames per second, but you can control it 30, 20, 15 frames per second. You also have a high frame rate camera that will record at rates of 100 frames per second.
All right, and I know I'm getting a little echo. Thank you, Thomas, for telling me. So We just have to bear with that because we're both in the same room. So that's why. All right, I'm going to close the poll. And thanks for participating. 56% of people are currently using video. So back to you, Frazer.
Okay, perfect. Welcome back, everyone. Thanks for participating in our poll. Okay, so what I'm going to do is run through a single camera setup, and there's little bits and pieces. This is the camera I'm using, as I mentioned. It's just a very generic USB Microsoft LifeCam, simple plug and play. The key part to using these and getting the synchronization taken care of is finding a way in which you can synchronize. You've got this little LED video sync cable. Basically, one end of it will plug into an MP160 or an MP100, and the other end has an LED on it. And I'll show you that live in action in a moment. And what we do is we use the onset of the LED to determine when we're synchronized to the physiological data. So this image here shows two things. On the right-hand side, you can see the LED illuminated. And on the left-hand side, in Acknowledge, you can see there's a square wave. That square wave was an output from the stimulator that turned the LED on. And what we do is we synchronize, we send the stimulus to the LED, and also we record it at the same time. And then by recording the same signal, we know precisely when the LED was illuminated. And when we go back to the playback viewer, we can find the point that the LED came on. And then using the controls within the media feature, we can adjust the delay between the video and the LED. And once we get that dialed in just right, you can see the precise point where the signal goes high for the stimulus output. In other words, when the LED turns on, those two should be precisely aligned. So that's the theory. Let's see if we can put that into practice. So I'm going to come back over to Acknowledge, and I'm going to turn the video back on somewhere down here. Here we go. This is the LED that I'm talking about. So what I'm going to do is when I set everything up, I'm going to set the stimulator so that this is illuminated. Normally what you do is you have this in proximity to the participant. They don't need to be holding it like this. As long as the camera can pick the light coming on, that's all you need. And then when you go into the playback mode, it's very easy to align the stimulus or the point where the power was sent to turn the light on with the actual illumination of the LED in the video. So this is very similar to that image I showed you in PowerPoint. You can see I've already recorded this once. I've got a square wave going from 0 to 5 volts approximately, and that's what's going to illuminate this. Now, how we set that up, suppose if I move my camera, okay, on the front of the MP160 system, you can see down the bottom here, this is an output, and I've got a little splitter. So one end of the splitter is coming to my LED, and the other end is feeding the signal back into channel 1. So I've got basically the same output going to the MP160 and to the LED. Okay, so it's pretty straightforward setup. And camera back up here. Alrighty, so in the MP160 menu under Setup Data Acquisition, This controls everything to do with running your experiment. This is where you turn your channels on. This is where you control the stimulator. So I am just recording one channel. I've got the HLT connected to the analog output. If I come under stimulator, I can create a square wave output, and I'm outputting this once. So I've created a 2-second delay. So this first period here is 2000 milliseconds. And then I've got a 2-second pulse wave, 2000 milliseconds, set to 5 volts. And I'm just going to output that once right at the beginning when I start to record the physiological data. So if we close out of here, I'm going to set this back. Okay. So we're now back at 0, and I'm going to turn this around so that hopefully we'll be able to pick this up. I hit start. Sorry, that wasn't very helpful. Let me do that again for you. And I'm going to turn off the playback viewer. And we'll do that again, and hopefully this time you'll actually get to see what happened. Okay. All right, so let's try that again. So I hit start. And the LED came on, and we see the square wave pulse. Now I can hit stop. So now I'm going to open put the LED down. I'm going to open the playback viewer from the media menu. Okay, so this is the playback. Wherever I place my cursor, it advances to the corresponding frame. And in theory, over here, where the pulse went high, the LED should be lit. Now, hopefully you can see that. The LED is lit up. I'll leave that on the screen a little bit in the hope that you'll get a good view. If I move back along here to the left, right here you can see I've placed my cursor before the square wave, before the 5 volts were actually introduced to the LED, and the video is telling me that it's already illuminated the LED. So I can see that there's a lack of synchronization. I'm just going to slowly move the cursor back. So this is right on the threshold. If I move the cursor once to the left and once to the right, we can see it's the difference between the LED coming on and actually being off. And I'm going to zoom in a little bit so we have a better view here. Okay, and I'm going to place my cursor again. So if I scroll this along, at some point the LED is going to come on. There we go. So that right there is where the LED is coming on. So what we need to do is we need to determine the time difference between these 2 points. And if I adjust my measurements, and I'm going to set these up, I only need 3 measurements. So now we have a better view. Using the measurements, there's a measurement in here called delta T. So this is going to give me the time difference between where my cursor is blinking. I'm just going to put my finger on the shift key, and I'm going to click on that upward line. Actually, I didn't do a very good job of that. And I'm going to redo that. So let's find that point where it came on, right there. And then I'm going to, there we go. So that's a little bit better. So this time period is 185 milliseconds. Okay, that's the difference between when the video is coming on and when the pulse went high. Now, if we come into the media menu and go to setup, I'm going to the linked media. So this is the linked file, and I'm going to select edit, and I can add in that delay of 0.185, actually, of 185, and hit OK. Okay, so now if I click my cursor just before, you can see the LED is no longer lit up. And if I just scroll through, it's still not lit up, it's still not lit up, and it should just about now, there it is, right on the upstroke of my LED. That tells me that the video is now synchronized with the physiological data. So any other signals that I was collecting at this point, I know that what I'm looking at on the video is now perfectly aligned with the physiological data that I've collected. Now, the nice thing in the playback mode, we can come over here. I'm not sure how this will work for you guys, but if I hit play, we can play back the video and we can see exactly what's going on. And it's going to come to an end. And now if I come back, it basically passes the cursor through without having to do this manually. So very quickly we can get a view of what's going on. Okay, so that gives you a nice example of how we synchronize between the video. That was the out 103, very simple LED connecting to the analog output, coming into setup stimulator, and I just created a square wave, 5 volts. That's what's illuminating the LED. And then when we come into the media playback and we go into setup, come under linked media, it's now showing us this delay that we added of 185 milliseconds. If I come into edit, we can add in whatever delay we want, whether it be positive or negative. And then once we've done that, the video should be properly aligned with the physiological data. Okay, so there's one other thing I want to show you while we're looking at this. This is a slightly different example. I'm going to maximize this. This is actually a video that was taken. This is one of our bioinormatics loggers. So the video on the right is showing the person just making sure that it's set up. You can see there's a little green dot just above the logger. That's the gaze point from the eye tracking glasses that the driver is wearing. Now, if I just advance this video forward a little bit, you can see the cursor moving and you can see things going on in the video. If you notice right at the beginning, try and see if I can get this where I want it. Right here. If you notice, there's a bunch of spikes at the top. These top 3 channels are the accelerometer inside the bioinormatics logger. You'll notice that the driver is placing the logger in a little cubby down in the center console. The accelerometer picks that up beautifully. So using the accelerometer and eye tracking glasses, you can synchronize the video really nicely. You can shake the logger while you're looking at it and use that instead of an LED, use the activity within the video and the accelerometer to perform essentially the same synchronization we did there. Now where it gets interesting, you can see how well this is aligned. So the driver's driving the car. I'm fast forwarding this a little bit to get to the interesting part and try and go a little bit slow. In this portion of the video, we can see the gaze point looking straight down the road. I'm not sure how well it shows up for you guys, but right here, there's a transition in the road quality. This is an asphalt road, and then it goes to a cobblestone road. And if you look closely in the blue and the green signals at the top of the page, you can see there's an increase in noise. That is the point where the car transitions from the smoother asphalt to the cobblestones. And just about here, right about here, we can see the car is now on there. So if I just play this video, now the car's driving over this rough surface, and we're able to pick that up. So the accelerometer is another really useful tool for synchronizing the logged physiological data with eye tracking. And this is the perfect demonstration. Someone driving a car, the physiological signals are coming off. We're actually looking at ECG, respiration, pulse, and electrodermal activity. And you'll see we're just approaching an intersection here, and the transition in the road occurs again. And now we're turning onto a much smoother stretch of road, and just gives you a good idea of how easy it is to synchronize these things. So I'm going to get back into PowerPoint. I'm going to hand you back over to Brenda for our second poll of the day.
Okay, thanks. I'm going to mute you, Frazer, because otherwise there's an echo. And I'm going to launch the poll for everyone. How many participants will be in your experiment? A single participant or multiple participants? And then I know some of you are telling me about some Wi-Fi problems that you're having or bandwidth problems, but other people are reporting that it's going well. So, so just hang in there and know that we are recording this. If you're one of the few people that are having some Wi-Fi problems or bandwidth problems, then you know, then you can review it in the recording as well. I am seeing the video coming through clear, so so I think we're mostly good. I think there's a few people that are having trouble with the GoToWebinar part, though. All right. Well, thank you all for participating in the poll. You can communicate with me in the questions panel. Again, just letting you know. And thanks for your feedback. I see you guys all reporting your bandwidth information back to me. So thank you for that. Frazer, is there a way to, I'm going to have to unmute you, but is there a way to efficiently classify different behaviors in the video files, or is that something you're going to cover? And I'm going to unmute you right now.
Okay, yeah, that's a great question and something I can cover. There's a couple of options for doing that. There's a really very elegant event marking system within Acknowledge. So in real time, you can pick out certain behaviors, yawning, coughing, standing, sitting, marking whatever type of behavior is relevant. And then the system will provide you with all kinds of information concerning the time that that occurred. You can mark the duration as well. So you can do certain things. However, if you really want to get super sophisticated with, you know, lots of different types of observations, another alternative is to use something like Observer, and Acknowledge can bring in the Observer files as well, so you can synchronize the observational data with the video and the physiological. So it sort of depends a little bit on how complete and complex you want to get with that type of observational information.
Okay, thank you, and thanks for participating in the poll. 51% of people are doing single participants and 49 are multiple. Thank you all for participating. Back to you, Frazer.
Okay, thanks everyone. Thanks for the polling and the questions. All right, so let's move on. What I'm going to talk about now is the multi-camera. So I think Brenda said approximately half of you are doing multi-camera setup or multi-subject. So you may already have camera systems in place. If you don't, BIOPAC offers two packages. One is a 4-camera, one is an 8-camera. What I'm going to be demonstrating is the 4-camera system. The only difference between the 4 and the 8 is basically the number of cameras. So let's take a look at how this works. And Brenda, I'm going to ask you to connect me to the other computer, if you don't mind, please. Did you make me presenter on the other one? Yeah, I got it. Yeah, no, we're good. Okay, so welcome everyone. Let's get some of this junk out the way. I'm using this on our lab computer. Welcome to the BioCube. Brenda is sat in one of the cubes. Sadaf is sitting in the other. Sadaf has kindly volunteered to be a subject. So I have physiological data coming up from her. This was sort of previously recorded. I just wanted to kind of give everyone an example of how the 8-channel system or 4-channel system in this case works. So what we're looking at here, Sadaf is actually, and Brenda for that matter, they're both sitting in the media chairs and they're looking at a video screen, a monitor. Basically everything is built in, all the cables and everything else. It's a little bit cool in here today, so Sadaf's trying to keep warm. Hopefully we'll get some decent signals from her. Brenda is actually trying to moderate at the same time, so we're not collecting data from her. She's multitasking. The way this is set up, if I come into the into the media menu, go into setup. Before, when I was showing you from my laptop with the USB camera, I was using the Microsoft camera. Here, I'm using our USB device that connects to the system, and then that allows us to control the bank of 4 cameras. We can also control the audio as well. I'm not using the audio. The way the lab is set up, Sadaf actually has a set of headphones adjacent to her with a microphone in front. So I can communicate with her. The same goes with Brenda. We're not using that today because I'm trying to communicate with you guys at the same time. But this is essentially the setup that we've got going on here. We're outputting to this untitled ACQ video.dmv file, which is basically the same file name that I've got at the top here, untitled. I'm going to close that out. If I come into the MP160 menu, I've got this set up so that I'm recording electrodermal activity, ECG. I had the LED connected, but I realized it was easier for me to give you a demo of the LED with me in the control room, so at the last minute I removed that and just brought it into the control room. And we've got respiration. So that's everything set up from the physiological aspect. Hopefully, if I hit start, we'll start to record live data. And we can see we've got a pretty healthy ECG signal coming from Sadaf. Look at EDA, she's a little cold, we're not getting too much going on over there. But here we are, we're able to monitor our participant. If we put a video on or something like that, we can actually show the video. The one that's saying loss, that actually is also picking up the media that's being presented, and in a second we'll probably see something come up on the screen. I'm not sure how well that will show up for you guys, but it just gives you another idea that you can actually record any presentation that's being given. Here we are, we're able to see Avatar play. It may not be coming through great for you guys, but Sadaf sitting there watching Avatar on the screen, chilling out, and we're collecting the physiological data from her. So pretty easy to set it up. The same synchronization applies. If I come over and hit stop, you'll notice that the footprint has changed, and that's because I'm actually using a portrait style monitor. And normally we've got two monitors set up here. We have the physiological data on the big portrait monitor, and we have the camera set up on a regular monitor adjacent to it. But because with the GoToWebinar, I'm unable to show you both monitors at the same time. I'm doing everything on the portrait, so it's probably tall and skinny for you guys. Hopefully you get a good view. So what I'm going to do now is open up the playback and bring the playback. Turn this off. Go to my second monitor. And there we go. So this is the video that we just recorded. And wherever we place our cursor, it advances to that portion in the video. Now, I don't have this super synchronized at the moment because I didn't go through with the LED. But it gives you a pretty good idea. If we hit play from this point here, it starts advancing the video, and we see the cursor moving through the physiological data. If I pause it, we can then come back through, set that up. Okay, now one of the questions we had a moment ago, someone was asking about how to score the data. So there's one option here. If we come into Setup Data Acquisition, for those of you familiar with the system, there's an option under here for event marking. And we can set up a bunch of hotkeys. And I can say, okay, when I hit the F1, my participant is coughing. If I hit F2, they looked away, so on and so forth. Oops. Looking away. So now when we come in, close this, I'm going to rewind everything back to the beginning. So we're now back at time point 0. I'm going to close this window out. I'm going to open up the capture viewer. So now we're back to live. If I hit start, now recording, and if I hit F1, you can see there's a little red diamond that's being placed up above, and it's marking it with coughing. And come in with F2, looked away, and we can close those out. And then when we stop recording, it's a little challenging on this display. Let me just adjust this a little bit so we get a better view. Here we go. So down over here, we have a list of the events that were put in there and the channels that were collected. I can make this a little bit larger. Okay, so we can jump to that point, and actually what I should do is close this out and open up the captured. Let me close this for a second. So we're back to the playback viewer. If I open this back up and move this over, this is taking me precisely to the point in the video, and all I do is I just have to jump down, and it's advanced me to that point. We can go to coughing. So now we're at the coughing point, and right there we've advanced the video to that point. So this is one way of doing it. You can also do the same offline using the event. So it's efficient if you're doing a limited number of observations. If you want to get more advanced, then you probably want to use something like Observer. Then when you come into the analysis menu, you can import your markers from Observer, and then all of those markers will come in and you can perform all kinds of analysis. We can also bring in the event markers from Superlab or ePrime or whatever stimulus presentation system is being used. We're just showing you a video today, but if we were using ePrime or Superlab, any event marks that are coming in, those will also be synchronized with the physiological data. Okay, so I'm going to hand you back over to Brenda for the final part of my presentation.
Okay, hi everyone, and that video looked really good. I was pretty happy about that. I'm launching the poll. What type of subjects, human or animal? And while that poll is launching or live, you just showed how to do event markers, so that was one of the questions that came in. Let's see, timing sync between recorded video and bioinformatics. I think you talked about that because you were showing that 185 milliseconds. Is there anything else you want to share about that?
No, we can control that.
Oh, hang on, I got to unmute you. So, okay, now go.
Yeah, we can control that, and there's also a feature within Acknowledge that will control the wireless delay as well, so you can account for that if you're looking at bioinformatics and other tethered signals. So the system's smart enough to account for all of that.
Okay, I am going to close the poll. 79% are videoing humans right now, or subjects are humans. So thank you all for participating. Frazer, back to you.
The computer again, Brenda, that would be awesome. Thank you. Perfect. Okay, welcome back, everyone. So the last piece of the puzzle is the high frame rate. I don't have a demonstration of this. It's a pretty sophisticated camera. Big difference between the camera systems that I've shown you so far and the high frame rate camera. The high frame rate camera is fully controlled by Acknowledge. So Acknowledge provides the timing sync signal that drives the camera. And we're using a Gigi camera. This camera doesn't have the lens on it, but the lens clips on the front there. It communicates via Ethernet, and then it's got its own individual power supply. It comes with a stand for mounting, so you can mount it adjacent to the participant. One of the nice things about this camera, it's really designed for people that are doing rapid types of transitions. We've got a nice demo that will play out really well. I don't think it will work well for a webinar, but it shows someone jumping from the floor onto a step stand, and then looking at the frame by frame transitions, you can see precisely the point of takeoff, you can see the point of landing, you can see the person as they're traveling through the air to the point where they land on the step, and vice versa when they jump back down the other way. So the high frame rate camera is really designed for applications like this, where you need to have really good resolution of what the person is actually doing. The videos that I've shown you, the quality is actually pretty good with these, but it's really meant to be based around, you know, subject observations. Normally, I've got the lighting a little bit subdued in here today. We can turn the lighting up. The cameras will handle that no problem. So you get a better view of the participant. We can also combine this with facial coding and eye tracking as well. So you kind of can synchronize everything. You get the video of the participant, you get the eye tracking information, any facial coding that you're doing. All of that is built in, plus the event markers coming in from ePrime, et cetera, et cetera. So it kind of gives you a good overview of what we can do with video synchronization to physiological data. I'm going to hand you back over to Brenda for any final questions.
Okay. Thanks, Frazer. Wait, I'm not unmuted. Okay. Let me know if you guys can hear me or not. I think you can hear me. So, all right. So there was a couple questions that came in. I'm going to have to go carefully here with the muting on and off. So bear with me. There's going to be a slight delay, but Vijay asked a question about how to get the data segment of coughing/yawning, i.e. T1, T2. Let me unmute you. Hang on. Go ahead.
Okay. I guess I didn't really understand the question, Brenda. Do you mean how to get to that data?
Yes.
The
data segment.
Okay, so when I went in, maybe you can switch back over to the other computer, Brenda, sorry.
Yep, no problem. There you go.
Okay, perfect, thank you. Okay, so after I had entered the events, I'm going to use there's a little laser tool on here somewhere. Drawing tool. Let's use spotlight. Okay, so right here where I've got this red light, there's a little diamond, and this is called the global event bar. And I elected to place the event mark in the global event bar, but if I wanted to, I could have put it on one of the channels. It just makes more sense for those observational marks to be in the global event bar. Over on the right, over here, under the event information, the event palette, I can open up and view all of them. So I'm just going to go back to normal. I'm going to click on this. So this is the event palette. And you can see this is where I looked away, looked away. These are the labels that I put in. And
can you make that bigger? It's really hard to see. You might not be able to on that large screen. Okay, that's fine.
Okay. So these are the ones, and when I click on them, it advances the cursor and the physiological data to that point. Okay.
And does that give you an exact time date stamp?
That's what we're looking at here. That's what this is.
It's hard to see, but that answers Vijay's question.
Yeah, the timestamp is there, and then also, if I just close this out, you can export all of this information as well. And if I mouse over here, it gives me that information as well. So this is 17.17 seconds. It was a type 2. Subject looked away, and it gives me the date and time information as well. So hopefully that answered the question.
Okay. All right, I muted you and I muted myself now. So let me see if I can ask this question here. Is there any synchronization solution also for wireless systems like BioHarness? Do you have an idea how to synchronize that in a video? We are using BioHarness right now, right? Oh, we're using respiration. Okay. Is that possible?
Yeah.
Oh, hang on. There you go.
Okay. So one option with the BioHarness has a transmitter, an accelerometer built into it. And as I showed with the logger, the accelerometer can be used to pick up information. So if you have the participant in front of the video and you shake the accelerometer, just shake the actual bioharness strap and review the X, Y, and Z, you'll pick up the point where the accelerometer changed very rapidly in the physiological data. Exactly the same way as when we saw the logger drop into the cubby, we saw those spikes. You can be a little bit more aggressive. And then you can use that, because you'll see in the video the precise point when the person shook the bioharness, and then you can perform exactly the same kind of synchronization that I showed you with the LED. So it is possible to do that.
Okay. All right, I've unmuted myself so that you can hear me more clearly. Another question is it possible to synchronize EEG data in mice with video? Oh, hang on, let me unmute you.
Okay, perfect. Okay, so you can perform the same type of test. If you have an LED somewhere in view of the camera, you can do it that way. You just need some mechanism for doing that. I do have a very nice table which gives you the sort of degrees of synchronization you can expect to get from systems at different resolutions. And a lot of times the difference is actually not that bad. So dependent upon how precise you really need to be, it may not be too much of a problem. 180, 200 millisecond offset, for some people, it's not that much of a problem, and they don't even need to do the synchronization. However, if you do need that precise synchronization, you've got to have some mechanism for doing that, either the visualization through the LED coming on, or maybe, that's probably the best way. Using the video would be the LED would be my recommendation, and trying to set that up at the beginning so the LED is within view, even if it's just temporarily held in view. And then once you've captured it at the beginning, you can take the LED out and let the system run for long periods of time. Usually what we recommend for those of you that are doing that, I'm not sure which computer we're running now. Are we still on the tall, skinny one?
Yeah, so tall, skinny.
Perfect. Okay. So one of the things we recommend is coming in to set up data acquisition. Acknowledge is running on a 64-bit application, so it can handle really large files, but we typically recommend that you try and keep the files to a manageable size. So if you can set the system up to record, I'm going to give you an example. So right now this is set up to record to the hard drive, and I can set this to record for 6 hours, and I can repeat that forever. So basically what will happen is the system will start, it will run for 6 hours, it will stop, and then it will open up a new file and start again and move on for another 6 hours. So you end up with more manageable chunks of data rather than one 24, 36-hour recording. You basically end up with blocks of 6 or 8 hours, which 6 or 8 hours worth of data is still a lot when you're synchronizing to video. So it's just a suggestion that we recommend when we're working with those types of situations.
Okay. All right, I think I've got everybody muted the right way. All right, so Neek has a question. When using video in combination with physio data and for like E prime, can you do the delta T sync with each channel individually or only once? Hang on, let me unmute you again. There you go.
I'm not sure I understand the question, but I'll answer it the way I understood it. And if that's wrong, maybe Nick can chime back in. But when the event marks come into acknowledge, they are already synchronized with the physiological data. So that part is already synchronized. I think E prime and Superlab, they get down to, I think it's about 1 millisecond or something like that between the presentation. One option that both companies offer, if you really, really want to be super, super precise, is you can place a photodiode on the monitor that's delivering the different types of stimuli. And as each stimuli or stimulus is presented, you then get the marker coming from the photodiode. So then it's super, super precise. We get the event marker at the precise point the image changed on the screen. So that part is highly synchronized right off the bat. Then synchronizing with the video, we would do exactly the same as what we did at the beginning. We send out the pulse to the LED, and then we look at the timing difference there. Now, one other thing that we can do is we can send that pulse again later in the recording, and we can check to see what the slip is in the system and correct for it there. I'm not sure if that completely answered Nick's question or not. Maybe he can come back with a second approach if I missed the point.
He said perfect, thank you very much. And one last question, which you already covered briefly, is just how to import, or is it possible to import the observer data, the facial behavior, facial expression data into Acknowledge? And I know it is possible. So any other closing comments about that? No. Oh, hang on.
If you go to the analysis window, we have an analysis option there, Nodus, and we can bring in pre-recorded face reader data, markers from Observer, and we can export events to Observer. So any events that were entered in the physiological data that you want to move across into Observer, you can do that, or any observational markers coming from Observer can be brought in to the physiological data. And then BIOPAC can also natively bring in real-time the facial expressions data as well. So this is if you want to do it offline after the fact from Face Reader, bringing that data in, and then you can bring the video in as well. Alternatively, you would do the facial coding at the same time. So hopefully that answered that question.
Okay, thank you. And I have a few closing comments. I'm going to make myself the presenter here. So we just completed the Q&A. Thank you all for participating. I want to let you know that we have live and on-demand webinars on our website. You can just go to biopac.com/webinars to see the complete list. We also have a face reader webinar for people who are interested in that sort of information, since that came up a couple times. Our next webinar is December 12th. It'll be on non-invasive blood pressure. I don't have the title here because I didn't get a chance to add that last night, but please join us for that. Also, I want to let you know about our training event. So we have an event called T4, Tools, Trends, Techniques, and Technology. It's going to be in Santa Barbara in August 2019. It'll cover all kinds of hands-on training, how-to workshops, demos, specific lab time, one-on-one networking, lots of great information. So please go ahead and check us out on our website, biopac.com. And I have some last bits of information that I would like to share with you. Today's webinar was recorded. We will email you a link of today's recording plus the slides in the Q&A document. You can visit BIOPAC anytime for additional references, including webinars that I mentioned, other events like T4, screencasts, specific features and analysis tools, application notes providing step-by-step instructions, and there's a lot of other details that we cover on our website that are helpful to researchers. Frazer, anything else before we conclude?
No, I think we covered just about everything, Brenda. If anyone has additional questions, they can ask them after the fact and we'll get more information. There will be hard copies of all the questions and answers with links out to additional information on the website. So Brenda will send that information out at some point in the next few days. If that doesn't address the issues, then please contact us at biopac.com and we'll gladly help you out.
Okay, thank you so much, Frazer, for everything you did and setting up this webinar and presenting. Thank you all for attending. This concludes today's webinar. Thank you and goodbye.